Hi guys, good to see you again. And you know we have been looking at addition of inclined vectors. And I said in my previous lessons that we have basically 4 methods, but we shall be dealing with 3 of them. And we started with one in our previous lesson we called the triangle of vectors. It's a method by which we can find the resultant vector when vectors are added, inclined vectors are added together. And I also made a point that triangle of vectors can only be used when you are dealing with only 2 inclined vectors. And these 2 inclined vectors are supposed to be added together and to find the resultant vector. So we are still on triangle of vectors. Triangle of vectors. Triangle of vectors. And we looked at the steps to take. And I just want to recap what we did in our previous lesson. Then we can state triangle of vectors to your understanding. Now, we said if we can take any 2 inclined vectors at all. So I'm going to take one vector this way. Let me call this one V1. I'm going to take another vector this way. Anyhow. V2. And we said that in applying this triangle of vectors, what you do first is to concentrate on one of them, any one of them. And here, I will choose this. You know, the previous one, I choose the first one closer to me. I'm going to choose this one. So you see that whatever you do, the answer will still be the same. So I will choose this. And what I do is to draw this one again somewhere. Again completely somewhere. So I'm going to draw it. And don't change the direction, don't change the inclination, don't change the length. Never change anything about it. It's a vector. It must be warm. So I'm drawing it. So I will draw the vector again here. And this, the same vector V2, I've brought it back. And I'm going to take the other one and I'm going to join it with it. Join this one to that, such that their arrows will follow a sense of direction. So somebody can decide to take this vector and put it here. Watch it carefully. Put it here. That is V1. And he's right, because the arrows are pointing in a sense of direction. He's right. Somebody can decide to also put it here. Take this vector and join it over here, over there, and this is V1. And you also, all right, either you join these 2 this way, or you join these 2 that way. What do you use to check? What do you use to check? It is the arrows. The arrows must not oppose each other, but they must follow a sense of direction. Sense of direction. All right, so I would decide to take this one. Now, if you take this, you get the same answer. So when I take this, the next thing we said you do is to draw a triangle out of it. And how do you draw a triangle? You only draw a line to complete it. I'll draw this line. This line to complete the triangle. And that line I have drawn to complete a triangle is representing the resultant vector. That is all. And I'm going to use V to stand for the resultant vector. So you ask yourself, it's a vector, so it must have an arrow, it must have a direction. Now, the reason that went into it in our previous lesson, I'm just trying to send your mind back to what we did in the previous lesson. We said that this resultant vector is taking the place of these two. I mean, you put them together and you are getting this. So this one can take the place of the two. All right, so let's check. We are concentrating on the two vectors. And when you check the two vectors, they start from here. Can't you see it? Together, they start from, look at the arrows. They start from here. And they travel this way, and finally they end this way. So they start from here, and they end this way. Now, if this one is to take their place, then it's also going to start from here, and it would end there. So the arrow will be on it like that. And as I said in my previous lesson, I said it is always good if you can put two arrows on it. In fact, if you put one arrow, nobody will mark it wrong. That one, nobody will mark it wrong. But I choose to put two arrows just to show that this one is the answer, the resultant vector I'm looking for. Now watch this. I think you have followed me. Now, I'm going to state the triangle of vectors. I'm going to state the method we call triangle of vectors. So now follow me. When two vectors acting at a point can be represented in magnitude and direction. Watch my hand. Can be represented in magnitude and direction by the sides of a triangle taken in order. Did you hear that? Taken in order. The resultant vector is represented in magnitude and direction by the third side that completes the triangle, such that the three vectors will remain in equilibrium. Will remain in equilibrium. It means that they will remain calm. They will remain in stable condition. The three of them put together, they will remain in stable condition. Let me repeat it. Again, you watch my finger. When two vectors acting at a point can be represented in magnitude and direction by the sides of a triangle, or by the sides of a triangle, taken in order, the resultant vector is represented in magnitude and direction by the third side that completes the triangle, such that these three vectors will be in equilibrium. Students, that is all there is to it by stating the triangle of vectors. That's all there is to it. Now, let us take a question. Again, to clear any doubts in our minds. Clear it off. And the question reads, two vectors acting at a point are represented in magnitude and direction as follows: 6 newtons, 040 degrees, that is in bearing, and the other one is 10 newtons, 150 degrees, all put together in a bracket. Now, find the A part of the question. Magnitude of the resultant vector. The B part says that find the direction of the resultant vector. Let me repeat the question. Or are you okay with it? Okay, I hope you are reading along with me. The question, you are reading along with me on the screen so you don't have any problem. Now let's go ahead and solve it. Now, we are told that, so that is the solution. The solution to the question. We are told that the two vectors are represented in magnitude and direction as follows. We have 6 newtons, 040 degrees. And that's supposed to be the bearing indicating the direction. So you see, this is the magnitude of it, and this is the direction. And the other vector is 10 newtons, 150 degrees. Again, expressed in bearing. These are the two vectors. And we are supposed to find, first of all, the resultant vector. In other words, when you put them together, what will you get? And what you will get is what we are calling the resultant vector. So first of all, before you can join them and join them well, you should be able to draw them individually. You should be able to know how they are represented in the form of a diagram individually. And I know we have done it before, so you have no qualm, you have no trouble. Let's see how we are going to draw them one by one. Now, when I take this vector, this is how it is drawn. On a bearing of 40 degrees. And you know bearing, we start from the north and we go clockwise through an angle of 40 degrees. So I'll go through an angle of 40. So I start from the north through an angle of 40. And this is the vector. I know, do you remember I said that all vectors will always start from the cross junction here. This is how where they start. They start from there. So they all start from here. And this is the angle 40. And what is left here will be 50. And I'm going to put the magnitude 6 newtons on it. So it means I have indicated so that you see it clearly. Allow me to do this, right? I'm going to erase this and use a red pen. I think it's better we do it that way. And this is the vector there. How do we draw this one too? Again, I will draw my north, my cross line, put my north here, and I travel through an angle of 150. So I'll start from the north and I'll go 90 here. This is 90. I've gone through 90 from here. This is 90. Okay, you ask yourself, what do you add to 90 to get to this angle? You have to add 60 to 8, 60. So it means I'll go additional 60 and I have my vector. My vector. And that is supposed to be a vector of magnitude 10 newtons. So I'm going to put a 60 here. 60 here. So this vector is making an angle of 60 with the horizontal. This one is making an angle of 50 with the horizontal. The rest are all there. That is it. That's the steps to take. We want to solve this question. So we have to draw the vectors individually. And we have done that. Now watch carefully. Because the magnitude is 6 and this one is 10. This line should be shorter than this. In other words, this line should be longer than this. do you remember we said the length of the line is representing the magnitude? So there's no way I can draw this one to be longer than this. I can't do that. So when you draw, you can check. You draw and look at it. Oh, this one is almost, let me erase some part of it from there. You just do it. We just do it. We want to be scientific. We want to be on the right path. Now, after you have done that, now, so that I can erase this part. After you have done that, what do we say we do? We take one. We take one vector. We draw it again. We take the other one and we join it to the first one so that their arrows will follow a sense of direction. So you decide which one to take. You can take any one at all. Any one I've told you. You can start with any one. Let me start with this. Somebody can decide to start with this. That is no problem. It's no problem. I'm starting with this one. So I will draw it again. This time I should be very careful not to change the direction. All right, so I'm going to draw it again. And I have this. And this is 6 newtons. Then I'll draw the other one. I'll bring this one and join it over here so that they will follow a sense of direction. So I'll draw this down. And this one should be longer than that. And I'll put 10 newtons here. So then step by step. So once I've been able to draw them individually, I can now take one and then join it to the other one. And this is what I've done. Now, you ask yourself, what is this angle? What is this angle? This angle is so important to us. They are joined together at what angle? We can go here to look at it step by step. Please, there's no problem. Now watch this. If you look at it carefully, this is the vector. This vector is this one. And the angle we are talking about here is this part. Can you see it? Look at the arrow. And look at this arrow. It means if this angle we are talking about, then we are talking about something here. Here. All right. So we ask yourself, this vector, what angle is this vector contributing to this angle we are talking about? This one, how much is this vector contributing to this angle? We can do it. And look at it. If I should draw a line down, let me put the 6 newtons here. If I should draw a line down like this, we want this angle. How much this vector is contributing over here? If I draw this line, vertical line down, do you know the name we give to these angles? They are called alternate angles. And the alternate angles must be the same. So it means that this angle here and that angle here are all 40. All right. Then watch it. I'm also going to draw a line vertically down here. Down. You know, I drew a line from this end of the vector down. So I'm going to do the same thing here, and I'll draw it down. What am I getting here? And the angle here is 40 degrees. You see? By algebra. Okay, you also ask yourself, again, this one, this vector, how much is this vector also contributing over here? Okay, this vector starts from here, down. And this angle here, as you all know, should be 30 degrees because this is a right angle. And so added together should give us 90. So this and that should give us 90, and therefore this is 30. Okay, look at it. It starts from here. It is also starting from here. Where the vector starts, it makes an angle of 30 with the vertical. Where this vector is also starting, should also make an angle 30 with the vertical. This is the vertical line we have drawn. Come on. And so together, their contribution put together, what are we getting? We are getting an angle of 70. So it means that this angle here should be 70 degrees. Then we want the resultant vector. And the resultant vector is that line drawn to complete the triangle. That line drawn to complete the triangle. That is all. And you agree with me that the arrow on this should be double. And it should point this way. Why? Because the two together, the two vectors together, they start from here and they end over here. They start along this direction. Watch my finger. They start from here along this direction and then down and they end here. So they start from here and they end there. So the resultant vector vein, which is representing the two, must also start from here and end there. So the first part of the question is asking us to, the A part is to find the, I'm searching for a space to work. Let me work here. So the A part of the question is asking us to find the magnitude of the resultant vector. The magnitude of this. Can't we use cosine rule? We have done that too. We have gone through that. Cosine rule. If you have forgotten, I beg you, go back. Go back. You will see it in one of our lessons. Go back. And by cosine rule, v squared is equal to 6 squared plus 10 squared minus 2 times 6 times 10 cos of the angle directly opposite it. And that should be 70 degrees. And when I move a step down, when I square this one, I'm getting 36. When I square this, I'm getting 100. Put together, I'm going to get 136 minus. So I have So I have it here. And that this will give me, this is 12, and that will be 120 cos of 70 degrees. And I have cos of 70 degrees. I have cos of 70 degrees to be 0.3420. This one. So I have 0.3420 multiplying 120, as you can see. So v squared is 136 minus that. Students, I hope you are following it. And when you move a step down, I have v squared to be equal to 136 minus, when you evaluate this side, you are getting 41.04. 41.04 when you evaluate this side. All right, so v squared, I'm here. When you subtract, you are getting 94.96. And so v will simply be the square root of 94.96, giving us the answer of 9.745 newtons. 5 newtons. So students, that is it. So you see, everything we learned before we actually tackled vectors, you see how important they are. We talked about, we went through cosine rule, we went through sine rule, we went through Pythagoras, we went through Cartesian coordinates and the others. They play a role. And you see the role the cosine rule has played in helping us to calculate for the resultant vector. Then at the next part, the B part of the question is asking us to find the direction of the vector. So interesting. The direction of the vector. And watch this carefully. Watch this carefully. We want the direction. This is the vector. The vector starts from here. And to find the direction, we need the angle here where the vector is starting. We need that angle. Very important. It will help us. You can never trace the direction of a vector at the end of it. No, where it starts. That's where we set for the direction. And it's logic. You can trace its direction from its starting point and not where it ends. So if this resultant vector starts from here, then we need to concentrate on this end to find the direction. So what we are going to do is first of all get to know the angle here I'm going to call this angle theta. Oh, come on, we can't use, okay, let me call it theta. So let's search for this angle. Let's search for this angle. And students, allow me clean this part of the solution so that we can have space to work for that. So we now know this resultant vector to have a magnitude of 9.745 newtons. We now know this. Okay. We want this angle. So you ask yourself, of all the mathematical identities that we went through, which one will help you do this? And which one will help you do that easily? And that calls for the sine rule. And what is the sine rule saying? It says this, that sine, it says this, that if you should take the angle sine theta and you divide it by that side, the magnitude of the opposite side, which is 10, the answer is the same as taking this angle, sine of the angle 70, and dividing by the opposite side, which is 9.745. That's all. This will help us find this angle theta we are talking about. And so sine theta will simply be 10 multiplying sine 70 degrees, divided by 9.745. Students, let's go here. All right. And sine of 70. So we have sine of 70 to be 0.9397. Then we divide it by 0.9745. I just substituted the value of sine 70 here, and that is it. So now let's move here. Students, we are moving here. So sine theta is simply, I'm going to evaluate this, and this is giving me 0.9643. So it means that theta will be sine inverse of 0.9643. And therefore theta from our calculator is giving us 47.64 degrees. Wow. Students, look at it. This whole angle is giving us 74.64 degrees. So you ask yourself, how can this one help to find the direction? We are almost through. Almost through. Students, watch this carefully. Do you see this vector? Do you see this vector? It is here. Watch this vector. 6 newtons. It is here. You see, you always consult these two you have drawn anytime you are getting confused. That is why it is important that individually you draw them. So we are going to do the consultation. Hey, how can this one help me do that? Okay, I go back to it. Look at it. If I should draw a line here, if I should draw a line here, you can see this line. If I should draw a horizontal line here, this angle here is 50. All right. So this angle here is 50. Already we have worked this whole angle to be 74.64 degrees. Do you remember that? We have worked it all. And that is it. So if this part alone is giving me 50 degrees, then it means that what is left here will be 24.64 degrees. So then let me write it boldly for you to see. So it means it is 24.64 degrees. That's the angle over here. And that is the end of our solution. That is the end. That is the end of our solution. So watch it, students. I will draw this vector. I will draw it, this resultant vector. I'm going to draw it alone. Put its value there, which is 9.745 newtons. And I'll draw this. I'll draw this line and put over here the angle we call the 24.64 degrees. This is what we have here. We just drew a horizontal line and we saw that if the whole thing is 74.64, then we went back to consult this vector. We made a consultation with that vector. And the vector is telling us that, if you should draw a line here, I'm contributing 50 for you. I'm just contributing 50. So what is left, you work for it. And we worked and we got 24.64. And this is what we are here. Come on. Once we know this, can't we start from here and draw our north and see from the north the angle we go through to get to that vector? So what do? First we go from the north through an angle of 90. We are here. Then we go additional 24.64. So together the angle is simply going to be 114.64 degrees in bearing. And you know, in bearing we don't have decimal points, so you approximate it and we are going to get 115 degrees. Wow. And that is the direction in bearing. So eventually you say that the resultant vector has direction expressed in bearing 115 degrees. Now, if you want to write the resultant vector in magnitude and direction, then it's how it's going to look like. Students, we put it in bracket. We got the magnitude to be 9.745 newtons and comma. And we have the direction to be 115 degrees. That is it. We will take another question. To again clarify and to clear any doubts again in your mind. We want you to handle vectors with ease. Just that you must be very careful you are dealing with vectors, and therefore directions, don't tamper with their directions. Don't tamper with them. And you go by the steps. The procedure is there. Go by the steps. Only that we need some mathematical identity. We employ them. And I will encourage you that those mathematical identities, further, you have to have a control over them. Have control over them. I'm telling you, have control. They are just mathematical identities and some bit of algebra. Don't worry. I will see you in my next lesson to solve another question for you. See you.